before we get too far, 7 pi over 6, that's the same thing as 210. That's why I said one or the other. Okay, so when you, if you need help with that, you'll want to search up a video titled Convert from Radians to Degrees or something like that. So doing these problems without a calculator, I recommend using these reference triangles. Okay, because if you just memorize these triangles, then you can do all trig functions evaluated at any of the normal angle measurements without a calculator. Okay, so look, the first one is isosceles. If one angle is 45, which in other words is pi over 4, right? So if you have a pi over 4 angle, then you're going to have square root of 2 over 2 and square root of 2 over 2 for the other sides, because a squared plus b squared needs to equal c squared. And both these triangles have a hypotenuse of 1 just because we've chosen the unit circle to work with. Could be any other circle, the ratio would stay the same, but we stick with the unit circle just so we all are on the same page with these. But okay, the long and short of it is, you remember these triangles and this process I'm about to do, you'll be able to do any sort of trig function without using a calculator. So the first thing to do is to draw 210 degrees. So here we are at 0, 0. Here we are at, we're at not 0, 0. Man, that's angle 0 is what I meant to say. This is 1, 0 on the unit circle. This might have been what I was thinking of, right? Because the unit circle has a radius of 1. Okay, but anyway, this is at an angle of 0 right here. This is an angle of 90 degrees right here. This is an angle of 180 degrees because it makes a semicircle. So 210 is a little less than 180 degrees. Okay, so if that's 210 degrees, we make a right angle with the x-axis, and the reference angle has to be 30 here, right? Because you're 30 degrees more than a semicircle. And so if we're able to put 30 degrees in for our reference triangle, which is always made with your terminal side and the x-axis like this, then we can label everything else in this triangle. What's opposite of 30 needs to be 1/2. But look, I'm going to label as negative 1/2 because we're below the x-axis, right? We're on the negative side for the y values. This is negative 1/2 for y values. Okay, and then this needs to be square root of 3 over 2. And again, it's negative. The reason why it's square root of 3 over 2 is because if this is 30 degrees and if this is 90 degrees, then this has to be 60 degrees, which means opposite of 60 degrees in our special triangles is square root of 3 over 2. And we draw them in the unit circle, so that's a 1. So we've got the whole triangle labeled. Now we're ready to do the secant ratio. Look, secant's the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant's just the hypotenuse divided by the adjacent. So look at your reference angle. The hypotenuse is 1, and then the adjacent is the one that's not the opposite of the reference angle. So this is the opposite, so that means this is the adjacent. So we're going to divide that by negative square root of 3 over 2. Okay, and then to finish this out, you'd want to flip and multiply. I'll keep the negative sign up top. And so that's it. It's negative 2 square roots of 3, but just make sure you rationalize the denominator in case your teacher's picky about that. You want to multiply the bottom and the top by square root of 3. That way, you have an integer in the denominator. So there we go. That's our answer without a calculator.